Hello, everyone, and welcome to this session. I hope you are enjoying the rest of the sessions and the conference at all. So today, in this next 45 minutes, we will be talking about Camel K and serverless. Camel K is this awesome framework to build functions and services on top of Kubernetes. So let's get started. A little bit more about me. My name is Hugo. I'm Mexican, currently based in Westford in the Massachusetts area in the United States. So here's also my Twitter handler if you want to follow us and engage offline with this conversation, or if you want to just share some feedback on this session. So the agenda for the session today, we will be talking first about serverless. We also will be talking about how can we implement serverless with Kubernetes, the different components of the platform. And finally, we'll be introducing Camel K and all the benefits that we can get with the Camel K Operator. I know that the title can be sometimes leading you to think about this platform, especially. Unfortunately, for this session, we won't be talking about this solution. So I'm sorry about that, but please stay with me. There's going to be interesting things from the developer's perspective that don't involve that platform at all. What are the main concerns when a company or organization is trying to get into that platform? Well, it is actually the vendor lock-in, right? When we're talking about the serverless platform or some kind of serverless solution that are offered in the market, most of them make you have this very deep commitment on the APIs and the solutions and the actual services that you can consume. So most of the times, us as developers will be thinking about a platform that can be run not only in just one provider's cloud, but it's also available to install on our own laptops. I know that it's sometimes complicated to merge these two topics, serverless and installing in your own laptop. But I do believe that we can do something around with the following components that we are exposing in this session. So let's talk about what is serverless and what are the actual capabilities that are interesting from this kind of providers that are offering a serverless platform. So the first thing is that they go beyond platform as a service. So they actually focus on code and how that snippet of code is being deployed on the service and on the infrastructure. And also, one of the benefits that you get from those platforms is the ability to be able to scale on demand. And this is not just being able to add more resources, but I think the key piece of this feature or this capability is actually the benefit of being able to scale to zero. That means that you will be able to idle or even shut down your services, meanwhile they're not being in use. So this will certainly lead to the resource optimization. So it means that we will be able to just allocate resources and the runtime from our platform, from our infrastructure to actually workloads that are currently running. So this is a very interesting capability of the serverless platforms. And finally, one of these important things when we're talking about the serverless platform is the capability of being event-driven. So the nature of a serverless platform involves events and being able to react to those events. This is mainly because we actually want to target near real-time latency where you're able to just see an event flow through the platform, being able to react to that event. So what are the other rest of behaviors that we expect from the serverless platform? Well, as we mentioned, as being an event-driven platform, we expect that we have some way, another system or another part of the architecture that is emitting events, that is generating these events along the platform, and then it is those events able to trigger the application or the function that is listening as part of the serverless application. So we are having these applications, these functions that are actually listening to the event bus, and then when an event is coming, then it triggers the the call to the services. So these functions and applications require to have certain features and certain conditions in before to be able to have a better understanding of the platform and to be able to perform better in the serverless context. So this is one of the things that you actually need to have in those kind of applications and functions. The first thing is a really fast startup time. It means that you need to, if you are waiting for an event to happen and then you are not running, you need to be able to react very quickly, and then being able to respond to those events in a very fast time. So we're talking about that less than a second to be able to react to those events. And there are other things, right? We can, if we are shutting down the application, we cannot have a state in memory, or we cannot be able to depend on information that it's already available, and so on. So how does it look from the developer perspective and from the application perspective or the platform perspective? So I, as a developer, what really want to focus on it's in my code, right? So what I'm expected is to be able to write stateless polyglot snippets of code that are using my own language, and then being able to push that code as just a snippet. So no need to think about what kind of platform we're running on, what are the dependencies to make the best use of that platform. Because that is what the platform does. So the platform should be able to take that snippet of code, my application or my function as it is, and then being able to compile, build, and package my application with all the required dependencies. And also it needs to be able to deploy it and create all the resources and configurations required by the platform to be able to interact with my service or with my function. It needs to create all this wiring between my application and the actual platform. And finally, the platform itself needs to be able to apply these scaling policies, being able to deploy as many instances as required, or shut the instance down if it's actually not any type of workload running at the moment. And this is being able to be accomplished by connecting to the event mesh and being able to handle the actual deployment of all my instances. So that's why we were thinking about a platform or an infrastructure that's actually been able to provide this capability. So Kubernetes, it's one of the cloud solutions, it's a very dominant infrastructure solution that can help us to provide some of these components. And how does it do that? It's through K Native. K Native has two main components that allows us to have these some of these capabilities from a serverless platform. The first one is K Native Serving. K Native Serving is the set of components from the solution that allows us to have this scale to zero, to be able to manage through a single route the way to access the service and when it's running, or to be able to trigger after a REST call it's received, and then start an instance of the service, and then being able to process my request. However, this is just a single approach to the solution. The other component, it's the one that also allows us to have a more complex set or more robust set of communication patterns with our services. And this one is Kinetic Eventing. Kinetic Eventing, it's a platform it's an abstraction layer on top of messaging. So we can construct this set of event bus or event management platform to then being able to trigger the Kinetic Serving services, and then being able to process our calls to the functions or services running on top of Kubernetes. Given a deep dive on Kinetic Eventing, while serving it's listening to an HTTP call, with the Kinetic Eventing we can have different sources of events that then will be able to trigger our applications. And also there's other patterns that we can use when talking about event consumption. So in this case, we can have a service that is not just a REST call as we just have with Kinetic serving, but we can also have other type of systems creating or generating events that are going to be pushed into the platform. So we can have a database that perhaps using change data capture to provide events, and those events that are ingested as source events into the Knative system, and then those events can be consumed using this abstraction layer on top of the messaging implementation, and then those events can be translated into triggers to that are hitting actually our services. And then we can have these kind of patterns like a fan out pattern where we have an event that it's coming into the broker, and then it will need to reach a different type of services at the same time. So this is one of the interesting things that Kinetic Eventing allows us to do on top of Kubernetes. And to make it more robust, we have different ways to implement all these pieces, right? So first, we can have our Kubernetes cluster with Knative on top of that, and then for the channel implementation and the broker implementation to handle these kind of events, we can have different options. The one that comes out of the box with the Knative install, it's the in-memory type of channel. So it's basically these type of topics or queues that are available just in memory and are volatile type of destination. But also you can use other type of implementations for those channels. So one of the interesting ones is using Kafka as a way to handle those events, so you can get all the benefits from replayable events and persistent events. And StreamC is one of these cool projects from the Cloud Native Computing Foundation that allows us to easy the deployment of Kafka on top of Kubernetes or OpenShift in the case of an enterprise version. But the problem is Kinetic Eventing is just for working on one single cluster. So when we need to share events that are being produced in not only inside the same cluster, but also in other type of domains of the same organization, like for example, when it's running on a service or on an application that's running still on bare metal or in virtual machines, it's when the event mesh makes more sense. It's this concept of being able to wire all these events, all these messaging technologies beyond the single Kubernetes cluster. It could be just trying to connect multiple clusters at the layer 7 type of communication to share just those kind of events, or it can even go beyond Kubernetes and being able to capture events that are coming perhaps from a legacy domain that is still running on virtual machine. So this is a brief summary of what Kubernetes can offer us to solve the Kubernetes requirements. And the Knative is one of the options to fulfill the requirements from serverless platform. The next step, if we already have the infrastructure set up, it's what is the programming model that we can use to achieve the benefits of the code and the snippets that we mentioned from the developer perspective in the beginning. So here's where Camel K makes a lot of sense to be used to fulfill these requirements. So Camel K, it's a sub-project from Apache Camel. Apache Camel is this long-term project that has been around for a while, specializing in connecting applications. So it uses enterprise integration patterns running on different type of runtime environments that create their own DSL, their own domain-specific language to be able to create these integrations and these connections. And one of the most important components of those projects is actually the connector system. There's more than 300 type of connectors that allows us to interact with systems in a very easy and standardized way, so we can get information from systems like Slack or Kafka or Salesforce, and then being able to process the information applying these enterprise integration patterns. So Camel K, it's a sub-project under the Apache Camel umbrella that it's actually an implementation of Camel on top of Kubernetes, and it's mainly focused for serverless workloads. So it gets all the benefits from running on top of Kubernetes in a Kubernetes-native way, but also if Knative is present, it also can get the benefits from that. It's a community project that tries to make these type of connections and runtimes running natively on top of Kubernetes. So how does it look for the from the developer's perspective? I mentioned we have this specific type of language, so we can create some services and implement our business logic. So we can create a snippet or a file where we can just start coding, and then we can use the provided CLI to just run or execute that file that contains our code, and then this CLI will be able to push the code and the file into the platform, and then the platform will be able to start all the resources to start running our application and creates all the required resources on top of the platform. This it's been done because the actual language provides us with all the information required for the platform to be able to decode what it's required or what we're asking them to do. So if you can see the snippet here in the middle, it says we are doing start from a REST endpoint. So we are calling it from, and then we are saying that we are calling a service run from the HTTP component. So the platform of Camel K will detect which components it needs to add as part of the dependencies. So here, because we need to add the Camel core, we also are adding the HTTP web server, and also because we are using a REST endpoint, we certainly need to do some serialization, some marshalling. So we are adding Jackson as one of the dependencies, and so on. Can detect what kind of endpoints or components do you want to add, and also it tells the platform to create this wrapper for my code, and because it's a very standardized way, you can automatically create the readiness and the liveness proof. So you're able to then deploy that as a Kubernetes objects as a deployment. If you're using some external configuration through config maps or secrets, those are also being created on top of the platform by the system. And as I mentioned, if you're using things like the Knative extensions, it will certainly allow you to create that deployment as a Knative deployment, Knative serving deployment, that it's getting all the benefits from a scale to zero. And if you're also having eventing, you are able to trigger the your application or your function as using those kind of sources. This is being done by the Camel K Operator. So the Camel K Operator receives this request to start our function, our code snippet, and it will take the decision to choose a runtime, then create this scaffold project, all the boilerplate components required to be a first class citizen on top of Kubernetes, create all the dependencies, do the packaging, the container image creation, on all the updates required to then be able to deploy that on top of Kubernetes. One of the runtimes that you can use, it's for example Quarkus, right? Quarkus is this platform and runtime to deploy Java applications that it's container native. It's super fast, and it allows you to have a very low footprint when running as a native image. So that's one of the things that we were requesting at the beginning. We need to have the capability to run our applications easily and fast to start serving and to start answering those requests from the serverless perspective. So we cannot wait a long time to start attending or to start processing the information. We just need to have these benefits of starting in less than 1 second. And Quarkus, it's a very interesting way to achieve this kind of capabilities. Also, the Camel K deployment, it's blazing fast because it does not need to create a container image every time we do a single change in our code, right? Camel K operator is intelligent enough to detect that if you are using actually the exact same um, components and the exact same dependencies on your new if you new code, then it can reuse images that were previously created in the past with the exact same signatures, and then being able to reuse those. And if some components added, like for example the one that showed in the slide, we can just add that as special, that specific component as a layer on top of the container image, and then deployment also can be very fast to deploy and then start working. You just not only get a fast startup time, but also a fast deployment time. But don't believe me, let's take a look at how can we actually get done with creating functions on top of Kubernetes K Native. Okay, let's start with the demo. So I have a OpenShift environment already, and I will install first the Camel K operator through the operator hub. In this case, we search for Camel K, so we can see the Camel K operator. And then we can install that as part of the community operators. It will create all the dependencies required for running on top of OpenShift. Here we're going to be installing and monitoring all the namespaces. So we'll use the defaults. As you can see, I have already installed some dependencies like MQ Streams, that it's the Red Hat version of Streamc for installing Kafka on Kubernetes, and also the Kafka operator for K Native, as well as OpenShift Serverless, that is the dependency for K Native. As you can see, the Camel K operator is starting to install, so we just need to wait for the status to be success. Okay, now it is succeed. So let's go to Apache Camel page, and if you go to Camel K, the documentation, we can get started. We need the download from the release page, the CLI tool. So the latest version right now, it's 1.1, so we can download, in my case, Mac binary file. Let's open a terminal. Let's make it a little bit bigger so we can take a better look. And now that we have already downloaded the Camel CLI, we just move to the serverless demo folder. Let's validate the version of Camel. So Camel version is 1.1 in the client. Let's log in into OpenShift using the OpenShift token. And we are in OpenShift. So Camel K will use this configuration. Let's create a namespace for our demo. In our case, it will create the namespace serverless demo. We'll be working on this namespace. So let's create our file, our function file. So it's going to be JavaScript. So it's going to be called translate.js. Let's open that in Visual Studio Code. Let's open the file. Currently it's empty. Let's start coding. So we're going to be using the Camel DSL. So we will be using a REST endpoint. So from the REST main root, we're going to do a post method, and we're going to direct to our actual implementation for this endpoint. It's called direct.translate. So this is just going to be able to decouple from the REST endpoint. So let's start with the from our REST endpoint that it's called direct translate. And now that we have the body from that, we are just gonna update and set a simple response. Set body as simple response, that it's gonna be hello world. And that's enough. This is the only code we need for creating an endpoint. Let's check it on a terminal. Let's open a bash terminal and run camel run, and then the name of our file, translate.js. We're going to be running on developer mode, and we will be applying this service on the namespace serverless demo. Because we are using the developer mode, we are getting the actual log from the Camel application. So this is what it's happening currently. It start to create the integration, as it's called, the services by Camel K, and it's currently building the container image. So what the Camel K operator is doing is it has received my file. It knows that it needs to create a container image that has this the REST endpoint and the web server. So it will create all the Kubernetes components. So if we go to the to our OpenShift project, let's navigate to serverless demo. Now we are on the serverless demo. We can see that under builds, Camel K it has created a Camel K build that it's currently running, and it's creating the container image. So it created a project, and currently it's building a container image that is the container image that is going to be used by my service to deploy. So currently it has updated, so it finished running the build process, and now it's starting my my service, my function. In this case, because we are running on top of a Knative enabled OpenShift cluster, we can see that it is available, so it will create a K Native service. And that's all. My application now is running. You can see this is the Camel K log. It start my Camel route, and it only took 0.117 seconds. So less than a second to create it. And if you go to the topology view on OpenShift, you can see that there's my service already running as a Knative service. So let's try it, right? We copy the URL, and then let's do a curl with a post method to that URL that we copy from OpenShift. And let's do the call. Yeah, that's all. Hello world, that's the actual expected result from our service. So it is working. It is connecting to the OpenShift cluster running on the cloud, and being able to get all that result. But now let's try, because we have a typo there. So it says world and it's missing a D. So let's save it, and automatically, because we're in developer mode, Camel K will detect the change and will update our function directly on the Kubernetes cluster. So we try another curl, and here it is, the hello world. Now it's fixed, and it's currently running on top of OpenShift, the Camel K updated. So let's do another update and add reload to the message, and then save, and then Camel K will detect that update and then redeploy the function. And we try to do again a new curl to the same endpoint. We can see now that the new message has been updated, and now we have our very nice hello world reloaded, being the return from the exact same endpoint. Pretty amazing, right? If we get back to the OpenShift console, the topology view, we can wait a few seconds, and we can see that our function, our service, it's going to be scaled down to 0. That's one of the benefits that we mentioned from serverless perspective, right? So it's terminating, and now it removed the pod. So there's no pods running actually at this service. So it's idle, and there's no resources being consumed by this function. This is one of the benefits from K Native, this scale to 0. So let's move this to the side, and then get back to our VS Code Studio. Let's try to call the service back again. Let's do the curl and request. Automatically, you can see that it starts to deploy and run our service, and voila, the answer is back. So it start the application, and the application it's back online, and it's actually serving my my post method. So if we can do another curl, we can see that we continue to get the same result from the the Hello World reloaded application. That was pretty interesting, right? That was pretty interesting, right? So we saw that we can create services and an actual business logic using Camel K as the actual service or the function, but also we can use Camel K for the sources for Kinetic Eventing, right? We were talking about we want to have these events being produced somewhere else and being able to push that into the platform. The way to do that in a standardized way is using cloud events. Cloud events can help us wrap the payload of events generated outside and being able to share that in the platform. So Knative and Camel K play well together because Camel K can take those events and then just create the cloud events required by K Native. It also allows you to implement the enterprise integration patterns that Camel is well known from. If you need to transform, do some certain management of your events inside Knative, you can use Camel K to do certain transformations and then put the new objects back into the platform. Or you can just do a direct connection and being able to trigger directly your service using Camel K components. So as we mentioned, there's this huge set of components that you can start using out of the box from Camel that allows you to connect to these systems, as we mentioned, like Salesforce, Google Sheets, Twitter, or Telegram, and then use Camel K to create those cloud events that are being propagated through the Knative platform as event source, and then you are able to use those events to be shared along all the platform. They being used to be triggering applications like your functions or your services that could be or not could be Camel K applications. It could be any type of application that is running on top of Knative serving. So how does it looks like when you're using Camel K as an as a component of the Kinetic Eventing platform? Well, let's take a look at this demo and see how Camel K can be used as a Knative source. Now that we know how to create functions with Camel K, let's use it as a source. So let's install the Apache Camel Operator for K Native. It's part of the community operators. If we install that, we are gonna listen to the whole cluster. We're gonna install that on the Knative project, and we can wait for that to complement the installation of Camel K as part of the Camel sources. So Knative brings out just a few type of sources for Knative events, and Camel K adds all the connectors available for Camel to start working with other kind of integrations to other potential systems creating events for triggering our applications. When the operator is installed, it makes the Camel source available as a way to define input for our Knative serving applications and services. So we can create Camel sources with this operator. So now we can then continue with our example. We are gonna replace our Hello World application with a actual translation service that it's accessing Google APIs to make a translation of simple text from English to Spanish. So now that we update our JavaScript function, we are able to deploy that. We are using an application properties file to provide the API key and some translation target and source. So we will be creating a generic secret with the application properties file. So we create this translate config secret from our application.properties file. And our serverless demo project or namespace. With this secret created, we can then do the run of our function translate.js file with the name translate service using the secret that it's the translate config in our serverless demo namespace. This will create the service to be running as a function. Now we can try and test that. So we're going to be doing a post, sending a JSON payload that it has just the text hello. This will take, the function will take the text from that JSON file and then send it to the translation service. And here it is. It's translate to hola. Let's try again. And now we can replace our hello with our hello world example. So we're going to translate this to Spanish, and here it is. Now we have our translation. It's hola mundo. But this translation it's only being called by using curl. So let's try to do K Native service eventing that we can then trigger with a timer. So let's create a channel on OpenShift. So we create a channel for receiving these events called translate input in our namespace serverless demo. Serverless demo. And because the default it's a Kafka channel, we can see when the channel is created, if we inspect into the YAML definition of this channel, we can see that the backend implementation is actually a Kafka channel for this channel, because that's our default implementation using MQ streams or streams for Kafka. Now it's time to create a subscription to listen on that channel. So let's create a subscription. It's gonna be called translate input sub, and it will define first a channel with it will be listening. So it's gonna be a simple channel, so we don't have a dependency on the implementation of the channel. The name of our channel is translate input, and then the service that we want to subscribe to be the subscriber, it's gonna be a reference to a service that it's actually running, that it's gonna be our translation service. So we can paste the information from the service that it's our translate service being created by Camel K as a K Native service. So we create this subscription. So we have our channel and we have our translate input subscription available now in the platform. So here it is, our service. Let's add now the camel source from the catalog, and let's do a YAML view. By default, the operator creates some examples, so you can use this as a reference to create your own camel sources. So in this case, we're gonna still be using the timer one. We're gonna just replace the reference of the channel that we are using. So we are gonna use the translate input, that it's just a channel, generic one. So we will be listening to that channel, and then we're gonna send events from that channel to that channel every 30 seconds, and then we're gonna replace the the body of the event with our JSON payload that it's again hello world. So instead of doing the curl, this timer, Camel K will be triggering this timer every time, and will be sending this constant to our service, and we'll be invocating the service with the text hello world. So we create this Camel source, and it will actually deploy a Camel pod that it's in charge of running this integration. So because this timer is already running, we see that the pod starts, and it's now listening to that event, and you can see in the log that now it's translating every few seconds the hello world into hola mundo. Well, now you can see that Camel K can be used for crafting services and functions that are the actual workload to be triggered, or also you can use the benefits of Camel K just to create certain event sources through Camel and connect to external systems to then being able to create those events that will be triggering your actual workloads. And your workloads can be of any type that are being able to be deployed as knative serving events. Camel K plus serverless, it's awesome, as you have seen. From the developer's perspective, you can get this fast, agile development type of environment where it's easy to maintain, that is just focusing you in the actual code, and you are delegating the rest to the platform. So it's very easy to have this magic dependency resolution, and then just focusing on the actual business logic. As an architect, you can see that we can reuse all these type of connection components that then leads us to do a resource optimization when using runtimes like Quarkus, and have the benefits of the actual platform to be able to do the tracing and observability provided by K Native. But Camel K is not just serverless. So Camel K, even though it shines when it's running on top of Kubernetes and K Native, it's not the only way to work with it, right? So you can still deploy Camel K on top of Kubernetes without K Native, and you will be able to deploy fast if you're running on Quarkus, or if you are using any other platform. You can still get the benefits of the traditional Java virtual machine, and it allows you to deploy these long-running applications that have a very low memory footprint, and you can use the different connectors and components to be able to craft your services and to orchestrate your microservices and add some connectivity to your application. So as you have seen, Camel K is not just serverless, but it works pretty well when we are using it on top of Kubernetes and K Native. Everything is being done as part of the Kubernetes custom resource. It's something that you can install anywhere where you can install Kubernetes. So it can run on your laptop, it can run on your own data center, or you can run in the cloud. It allows you portability and allows you to also being able to focus on the code and use a platform, a standard platform that allows you to run your exact same piece of code in any type of environment. I hope you liked this session. I really did enjoy sharing it with you. So please enjoy the rest of the sessions, enjoy the rest of the conference. You can also contact me through Twitter, and I hope it was something interesting for you. So thank you very much, and see you later.